Example 1 asks us to calculate the discriminant for different quadratic equations. So specifically it says, find the discriminant and hence determine the nature of the roots of each of the following equations. So make sure every time we go through an example that you're reading and understanding what it's telling or asking you to do. So it says to find the discriminant, and then therefore afterwards you're going to kind of know what the nature of the roots of each of the equations are. So let's start with part A. So A gives us 5x squared plus 4x plus 6 equals 0. So this is set up in the regular form of a quadratic equation, which was the ax squared plus bx plus c. So we can identify our a value, which is the number of squares, our b value, which is the number of regular terms, and then our c value, which is the constants or whatever is left over that is not attached to a variable. So to find b squared minus 4ac, we do b squared, which is 4 squared. Sorry, this stylus is kind of strange. Minus 4 times a, which is 5, times c, which is 6. So that value we're going to try to calculate. So 4 squared is 16. Now 4 times 5 times 6 is going to be 120. So we get negative 114. So negative 114, that is a number that is less than 0. When we have a discriminant that is less than 0, we get no real solution. So there are no real roots for this. Okay, so that's how that is going to work. Automatically, we can know we can figure that out. Now you'll start to see patterns emerge over time that could kind of help you figure that out. But once we know that the discriminant is negative, we're done. We know that the roots are going to be non-real, and we're not interested in non-real roots. So b gives us x squared equals 8 times x minus 2. Now this is set up. This is an equation. But it's not in the standard form for us. Now what that means is we have to make it into standard form. So we need to have it in this setup here. ax squared plus bx plus c equals 0. So the plus signs don't necessarily have to be there. They could be minus signs. We just have to adjust that later. But we have to have everything on one side and 0 on the other. That has to happen. So we're going to go ahead and alter this slightly. So the x squared is fine. If we distribute here, this 8, there are 8 x minus 2's. So if we were to break that up, that's going to be, we're going to have individually 8 x's. And if we have 8 negative 2's, we have negative 16. So we still don't have it in a full quadratic form yet. We're going to go ahead and we're going to move this to the other side. So we're subtracting 8x minus 16 and moving it over. Think of it basically as taking each part now that the 8x is separate from the negative 16, and we're going to shift them over so the 8x will become a positive 8x. Or excuse me, a negative 8x, sorry. And our negative 16, when we move it over, will become a positive 16. So now we have it in the right form. So now we can go ahead and actually use our form for the discriminant, and we can figure out how to get this to work. So again, we look for the number of x squareds is a. So we have, remember there's an invisible 1 here. So we have negative 8 x's, so that's a negative 8b is what b is. And then 16 is finally what's left over. So we do b squared. So we remember we have to do negative 8 squared, and that is going, and then we're going to subtract 4 times a, which is 1, times c, which is a positive 16, and then we want to try to figure out what this equals. So negative 8 squared makes 64. Be careful if you're using a calculator. Negative 8 squared you have to consider the negative and the 8 attached to each other. You can't leave them separate, so that's why I put brackets there. And then negative 4 times 1 times 16 is negative 64, so we have minus 64 here. And this is going to make 0. Now this means that we're going to have 2 real equal roots. When the discriminant is 0, that means we have 2 of the same roots, which is perfect. And lastly, we have 2x minus 1 times x plus 3 equals 4. So let's go through that. So we get 2x minus 1, and is that x minus 3, x plus 3 equals 4. So, sort of like the other problem, we have to do work before we can go ahead and find our discriminant. This is not set up in the standard way. So, in order to do that, we are going to do a little work right off the bat. So, to break up these two binomials, so binomials are little 2 parts, we have to multiply. So we do something called FOIL. So FOIL means we take our first terms and multiply them together. So our first terms, 2x and x, makes 2x squared. Then we do our outside terms. So f is the first. Our outsides are going to be 2x and 3. That makes a positive 3x or a positive 6x. We then do our inside terms, so that's the I in FOIL. We get negative 1 and x makes a negative x. And then finally, for the L in FOIL, we do negative 1 and 3, so the lasts. So that makes negative 1 and 3 makes negative 3, and then that still equals 4. So now what I want to do is I've distributed it out, and so now I need to get everything on the same side and combine. So what I have here, the 2x squared is fine. There are no other x squared terms, so there's no simplification needed. The 6x and the x here make a positive 5x. And then finally we've got our negative 3. And we're going to merge that with this 4. Now, so what happens in this case? So the 4 on the other side, we have to subtract it over. So it becomes a negative 4 on this side. And so when we do negative 3 and negative 4 together, we make negative 7. And that's going to equal 0. So now we can go and find our A, B, and C. So we've got A is 2, B is 5, C is negative 7. And so B squared minus 4AC is going to be 5 squared minus 4 times 2 times negative 7. Again, notice that it's very important now. This negative 7 needs to be in parentheses, okay, because it's together. We have so then we get 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times negative 7 makes a positive 56. So this becomes a positive 56. That together makes 81. Now, it doesn't matter what this number is, right? We know that 81 is greater than 0. So we're going to have 2 real and what is called distinct roots. So now that we have that, everything should be fine. Just make sure that we have everything set up at the beginning as ax squared plus bx plus c. If it's not set up like that, you got to do a little work. And once you get that work done, then you can find the discriminant. But you got to have 0 on one side. And also make sure to account for any negatives that are involved in the problem.